My name is Bob Buttrick, and I'll be taking you through a quick look at our data exploration and modeling notebook. So after our initial imports, we first start by fetching and preparing the data for modeling. So I have a handful of different functions here that do that. First, we're creating our two data frames based on some select statements, pulling the views that we created in our Lakehouse Gold location. So first we have our metrics data frame, which is high-level metrics aggregated by vendor. And then the second data frame is our main accounts payable line items. Quickly going through some of these functions, we just have some conversions to date time for a few columns. We're merging the two data frames together based on vendor. And then this final one just does some additional preparation, removing some columns we don't need, getting rid of any payments that are greater than 180 days late, just to reduce some of the noise due to outliers. And then finally, we're splitting that final data frame into our test or our training data frame and our final prediction data frame, which is just line items that have not yet cleared. Next, it's just running all those functions to prepare our data frames. And we can see our final count of line items for each data frame. So we have just under 17,000 line items that we'll use for training based on 12 months of data, and then 1,500 that will ultimately predict. So first we did a little exploration of the data, so just looking at the trend of the payment status category over the last 12 months. Some counts just get a feel for early, on time, and late. As you can see in the numbers here, majority are late, so that's what we'd expect to see coming out of our predictions. Quick look at distribution of the days early and late. Just wanted to see if it was a normal distribution or not. And the next step in our notebook is the actual model training and validation. So this first code block here is just a function that we put together that does some of the pre-processing needed to feed into the model. So we had some numeric and categorical transformers that we used, as well as just some general preparation, splitting the data frames into our train and test. So this is the results of our split. I just did a quick check just to look at the shape of the data, make sure everything's good to feed into the model. Also did another check of the distribution. I just wanted to make sure that the distribution looked the same between the train and the test data. Now onto the modeling piece. So decided for this project just to use the random forest model, which is kind of my go-to in general. In this case, technically the ultimate result is predicting a category, so early, late, or on time, but we decided to actually do a regression and predict the number of days, and then finally just convert those to the categories. Our logic there was if the business decides to change what those categories are in the future, saying, I think we have it set up as 0 to 2 days before the due date is considered on time. So if the business wanted to change that in the future, it'd be easy just to modify the code instead of retraining a model to predict the categories. So for the first step in this process, I ran a grid search for our random forest model. So we used all of these different parameters that it ran through. I believe there were 800 and some combinations that we tried with using 5-fold cross-validation. Once that completed, I grabbed the best performing parameters for our model, put them in here, and now we're actually training the models using those parameters. Here's the results of our model. So our training R-squared value is 0.93 and our test is 0.65. So obviously a bit to be desired on the test results, and the difference between those numbers between the training and the test kind of indicates some overfitting. So we'll have to circle back and do some additional tweaking to the model and possibly possibly some more feature engineering. Looking at the residuals, so most everything is centered around 0, which is ideal, plus or minus about 50 it looks like, with some outliers out there, but not too terribly. Next, we did a look at prediction errors. So this light gray line is the actual values. So that's the line what we would like to be at if everything was predicted perfectly. The darker line is what we're at, so a little off from there. At our feature importance, the top 30 features that made up 93% of the importance. And finally, here's the results of our training. So I just created a data frame that showed the actual days early or late, our predicted value, and then converted it into categories and ultimately the accuracy. Converting into categories actually increased our accuracy percentage as well, just being able to group in those buckets. So although our squared value didn't look the greatest through training, our actual accuracy is about 92%, which I'm happy with at a first pass on this model. And then finally, we're going to take that data frame that we created early on with our kind of unseen, non-cleared documents, run that through the model that we created, and then ultimately output what we need to feed into our Power BI dashboard.